Okay, so let's get to the second problem of our notes. Now we know that we're dealing with a logarithm function. Okay, so we have a logarithm function. They still follow suit with as far as the h. Let's go down here. Their h moving everything right to left. Our k moving everything up and down. Our a having a vertical stretch, and if there's a negative out front, that means it flips over basically that horizontal axis of some sort. Okay, so if you look at what we have here, all right, this is our regular logarithm function. This is our graph. We just saw it up here at the top here. That's what it looks like. Okay, so if we have it here, there's no reflection. If there is a reflection, you can see how it kind of just flips up and down. It flips sides from top to bottom. Now our vertical asymptote, is going to be x equals whatever h is. So h being whatever's on the inside next to that argument. And our point now will be the opposite of, so we'll say x minus our argument equals 1. So when we'll do one of these, if we have one with an argument, we'd have to figure that out. But understanding our baseline when we don't have any h or anything like that, it starts at 0, 1 for exponential and 1, 0 for logarithm. Okay? So let's just do one and see where we go with this, all right? So if we look at this, we have an a, and our a is 1. We have a b, our b is 2. There's our base. There is no h, so it's 0, and there's no k, so it's 0. So when there's no h and there's no k in this logarithm function, we know that it goes as x equals 0 is our vertical asymptote. Okay. We also know that we're going to use the point of 1, 0 as our baseline. All right. It doesn't have a negative out front, so it will be positive. Okay. Our domain is going to be, because we're talking about we're going from left to right, we're going to start at 0 and go to infinity. Our range for these will be all real numbers or from negative infinity to infinity. Now we got to find some points along the way here. So what we want to do is do that xy, if you will. And remember, when you plug in that 1, you're going to end up with 0. So I'd probably plug in 2 there. If you plugged in 2, so you have the log base 2 of 2, well, that equals 1. So now I have 2, 1, right? And if you chose 4, well, you have log base 2 of 4. Well, that equals log base 2 of 2 squared, which is simply 2 log base 2 of 2, which is 2 times 1, which equals 2. Hopefully you got all that. I'm sorry, I'm not showing you. I'm writing and you're not seeing it in the camera. So now we have 4 equals 2, which is right there. So now if we pick some smaller numbers, at the end of the day, you understand that it's going to go like this. It's not being moved. It's not going to touch that. That's the way it's going to look. Is it increasing or decreasing? Well, it's going from left to right. It looks like it is going upward, so it is increasing. Our vertical asymptote is at x equal to 0. Are there any transformations? Was there a vertical stretch? No. Did it go left or right? No. Did it go up or down? No. So there are none. Okay, so now let's go over these so make sure we're all hopefully somewhat clear. Baseline logarithm function, a is 1, our base is 2, there is no right or left, so our h is 0, our k, there is no up and down, so our k is 0. plugged in some points, found these three. Understand that since it doesn't move left or right, our asymptote will be x equal to 0, or basically along the y-axis. We plotted our 3 points. Understand it's going to curve straight down from there. It is a positive because there's no negative out front. It hasn't been flipped, so it's a positive. Our point is 0, 1. Our domain is 0 to infinity, and range is negative infinity to infinity. Vertical asymptote is 0, and there has been no transformations.